Okay, so this is 4.2. It's on page 214. All right, it says this in the velocity graph, velocity versus time. So I've got the velocity equation here, which is the derivative of position. Okay, that's the derivative of position. Answer the following questions. In the velocity graph at the right, let the units for velocity be feet per second. So that means position would be just feet. Okay, if you go back, position would be measured in feet. Okay, velocity, which is the derivative of position, will be feet per second. What would the units for the second derivative of position be, which is acceleration? What would the units be for acceleration?
Oh, like at A?
Well, no, I'm just asking generally. So I'm just interpreting the graph. Okay, so V of t is the derivative of position. They told us the units are feet per second. So that means I know my units for position is feet. My units for velocity here, this is velocity. Yeah, so then acceleration will be feet per second squared or feet per second, which is acceleration. All right. You should know that. That's just general knowledge. All right, here we go. Part A. They want us to know, is the acceleration, close that door behind you, Dante. Acceleration slope. And how do I know that acceleration is a slope? Because I'm looking at velocity. So the slope for velocity is acceleration. So tell me, A, is the acceleration going to be negative, positive, or zero?
Negative.
Negative. B will be what?
Zero.
Zero. C will be?
Positive.
D is?
Negative.
And E is what?
Positive.
No, negative. Slope's negative on E. I'm not looking for above and
But
below.
it's accelerating. It's going the opposite direction in speed.
That's speeding up and slowing down. I'm not worrying about that yet. We'll get to that in a second. Okay, I'm just looking.
Negative acceleration.
Negative acceleration, so it's negative. So E has a negative acceleration. Make sure you get your homework submitted, Dante. All right, so the slope is negative, 0, which means it has this means it's going to have a constant. It's going to have a constant velocity. Okay? C is positive slope, D is negative slope, E is negative slope. Acceleration, yes or no?
Yeah, I thought that was kind of dumb.
Yeah, I mean,
really don't.
yeah, that's dumb. This is yes, no, yes, yes, yes. Okay, I don't really get that.
Is there a slope?
Yeah, it's just asking, is there? I would assume so. So let me see here. Let me check real quick.
Yeah, I wasn't really sure.
Yeah, let me just check that real quick.
That seemed kind of silly.
Let's see here. That would be, I'm working on calc this morning, so you'll have to.
Oh, my quiz, you said I should take it.
Oh, yeah. So all you got to do, come over here. You need a separate sheet of paper. You got to write down the 11 fundamental identities from memory.
Yeah, what the heck?
Oh, I didn't know I need a separate piece of paper.
Just blank. You can grab one right in there. Yeah, that's what it was. So we're correct.
Shoot, I did this next part.
Yep, right in there. Just open that up. You can grab a sheet of paper. Okay, velocity and acceleration. Now, velocity is when this is velocity. So you're either going to look above and below and all that stuff. So it's above at A, and acceleration is negative. It's above at B, acceleration 0. It's above at C, acceleration is positive. It's above at D, acceleration's positive. It's below at E, acceleration is, sorry, I screwed that up on D.
Positive.
Yeah, positive, negative, sorry. Yep, just write down the one for tangent and cotangent. And then write down all 6 reciprocals, like sine and cosecant, secant, and then write down the 3 Pythagorean. Okay? So, and then that'll be negative, is that negative, negative?
Yeah.
All right, so then this means, are the signs same or different?
Oh, wait, wouldn't it be negative positive?
Where?
E?
E is negative, negative. Slope is negative and it's below the x-axis.
That's the thing you're talking about.
Okay, it slows down, constant velocity because of the 0, constant velocity. This one speeds up, this one slows down, and this one speeds up. Is that okay?
Yep.
Now, if I asked you where velocity was increasing and decreasing, I want to bring that up. This right here, acceleration, is where velocity is increasing or decreasing. Because remember, when you want to look at something, if it's increasing or decreasing, you just look at the derivative. So if you have a negative acceleration, it means the velocity is decreasing. This would mean the velocity is constant. This would mean velocity is increasing, velocity decreasing, velocity decreasing. It's not necessarily the same thing as speed increasing, speed decreasing. Speed increasing is where you speed up. Speed decreasing is where you slow down, which is different from velocity increasing and decreasing. And they will ask that. They will ask you where velocity is increasing and decreasing, which is just the slope, just acceleration. And then they'll ask you where speed is increasing, and just sit right there, Michael, or right behind, you know. And then they'll ask you where speed is increasing and decreasing, which is where you have to look at velocity and acceleration. All right, use the graph above the velocity to find the following. Show the computations that lead to your answers. How far does the particle move in the first 10 seconds? Does anybody remember, if I give you velocity, how you find the displacement area under the curve? So you're going to have to do the area of a trapezoid, the area of a rectangle, and in the area of another trapezoid and a triangle. So I'm going to bring this up today. You have to memorize the area formula for a trapezoid. Have to have it memorized.
What?
So, have to.
I just made a triangle. I went all the
No,
way
you
up.
need to know the area for a trapezoid. It's so much easier. It's 1/2 the height times the sum of the bases. Because there's a rule we're going to learn with integrals called trapezoid rule. And you need to know the area formula for a trapezoid.
All juniors signed up
So-
for the speaker this morning need to report to the studio.
You definitely could have done another rectangle and a triangle, but I'm going to do a trapezoid. It's so much faster. All right, so the height of the trapezoid is this will help you today because we're going to do a trapezoid with related rates. The height is always the one that's perpendicular to the two parallel sides. So these sides are the ones that are parallel, so those are the bases. And then the height is the one that's perpendicular to the parallel sides. So the height is 2, so it'd be 1/2 times 2. And then the sum of the bases, the base 1 would be, let's go 3 plus base 2 would be 6. So that's going to give you half of 2 cancels, and then you should get 9. So this is 9. See how much easier that is?
Yeah.
Okay, rectangle is length times, or height times base, or length times width, whatever you want to call it. That's going to be a 4 by, is that a 4 by 3? So that gives you 12. Is that correct? Thank you. I'll put that in the grade book for you. Okay, and then this is a 2 by,
It's gonna be 9 again.
okay, so this, is it 9 again? Yeah, it's the exact same thing. So then, and then this right here is 1/2 base times height. So the base, 1/2 base times height. So it'd be 1/2 times 2 times 6, which is going to be 12. Half of 12 is 6. So we know the displacement. These are all positive, so none of them are negative. If you have area, this one here, if you wanted to know this one here would be, it'd be a negative 4. So you get 2 times negative 4 is negative 8. Half of that would be negative 4. So then that displacement would move it back to the left. So if you'd have to, now that's not what they're asking. They're only asking to 10. So I only need these. So the total displacement from 0 to 10 would be 9 plus 12 plus 9 plus 6. So how far did the particle move in the first 10 seconds?
36.
It'd be 12, is that right? 18,
Yeah.
is that right? 36. So 36 units, which direction though?
Feet.
Or 36 feet, which direction though?
To the right.
To the right. How do you know to the right?
It's possible.
Positive.
Because it's a positive velocity, it's above the x-axis. So 36 units to the right. You having a talk with her?
Yeah.
So I'm doing participation grade every day. And yesterday she didn't do anything, so
Okay. Did you mean to text Tom Spencer?
yes.
About the dates you were gone?
Yeah, I'll do that. I'll copy and paste that.
Alright,
So.
Sounds good.
Thanks, buddy.
I'm glad you get time off though.
I know, it'll be fun. We're going to the Orange Conference, Andy Stanley's church.
Oh, that'd be fun.
Yeah.
Enjoy it.
Yeah. Average velocity is just change in position over change in times. So we just found, and they want for the first 12 seconds, so we need displacement
Area under the curve.
all the way up to
divided by
12.
Time,
Mhm.
right? But
Div-
it's the absolute value of
Nope, because you want average velocity. So velocity, you can
gotta
have negative or
subtract 4 and
positive.
you're not adding adding 4.
So you got to subtract 4.
Shoot.
Okay? So it's displacement divided by time. So you knew that this is 36, then subtract 4. So what's the displacement in the first 12 seconds?
32.
32. So it'd be 32 divided by 12, which will give you, that will reduce to what? What does that reduce to?
I don't know.
4 goes in the moat, so 8 over 3. 8 over 3 feet per what? 8/3 feet per second. Yeah, so look at this. You can see that. So look, displacement, see here in Gene's answer key. You have to subtract that 4 off.
Yeah.
Okay. When does the particle change direction? Well, the only place it changes direction, where?
10.
At 10, because the velocity goes from positive to what? From above the x-axis to below the x-axis. So you would take t equals 10. And you would say because, on the AP exam, you'd say because velocity changes from positive to negative. From positive to negative, which means it goes from moving right to moving left. All right, number 3. If a calculus book is dropped from a height of 100 feet, its height, s, at time t is given by the position. So here's my position equation where s is measured in feet and t is measured in seconds. Find the average velocity from 1 to 2. That's easy. That's just a rock. So that's just a rock from 1 to 2. So all I got to do is figure out my position at 2 seconds minus my position at 1 second. Always do end position minus start. Always go end minus start. Over 2 minus 1. Or you
I
need
gotta
to
do the one quiz that I was
the identities.
Yeah.
Grab a sheet of paper in there in my stand, or if you got your own sheet of paper, and come up here so I can see it, and just write down the 11 fundamental identities.
Okay.
Okay? It's in that thing. Just open that front. So S of 2 is going to be, you're just going to plug 2 in. What's 2 squared? 4. 4 times negative 16 will be negative 64. Negative 64 plus 100 will be 36. Is that 36? Minus S of 1 would be negative 16 plus 100, so that'll be 84, correct? Is that right?
Yep.
Yep. Over 1, and then what's 36 minus 84? Is that right? Negative 48?
Yep.
So negative 48, and it's feet per second. There we go, done with that one. All right, Hayden is standing on a ledge that's 32 feet above a mountain stream at time t equals 0. By the way, did you see in the last equation how it had negative 16 and it was in feet? And we know, remember, it's 1/2 gt squared plus v naught t plus h naught is that formula, where this is the initial height, this is the initial velocity, and this is gravity. And when we're in feet, it's 32 feet per second. So what's half of 32? What's half of 30? There's where the negative 16 comes from. And the 100 is the initial height of the object. It's being dropped from 100 feet. And since you're dropping it, there is no initial velocity. So this just cancels out. That's why there was no t term. Okay? That's the physics. They give you that formula on the AP exam if they do this. This one, again, 32 feet above stream. So this is my initial height. So there you got the equation. There's the 32. He jumps from the ledge into the water below. Hayden's position at any time t equals 0 can be modeled by this equation. So this one, he jumps, so he has an initial velocity. He jumps with a velocity of 16. Is it feet again? Yep, it has to be because it's negative 16 out front. Half the gravity constant, half a negative 32. All right, when does Hayden hit the water? You just set this equal to 0. You want to know when the position equals 0. The water is the ground, okay? So you would go 0 equals negative 16 t squared plus 16 t plus 32. What would you do to that? Did you slide it?
Yes.
A minus 2. And then you got to divide it by 4.
Yes.
So it's 1/2. So then it's going to be 2a minus 1, 2a minus 1, because you got to glide the 2 out
So
front.
that's the, okay, so I just write.
2a minus 1, 2a minus 1.
So these
And
are
you-
all right then.
Mm-hmm. Except for if you write it like that. This one you got to fix. You didn't reduce it.
I did. Divide.
We take
So it'd be
out
2x minus 3 and 3x plus 4.
So 2.
2x plus 3, because that was a positive. That was a negative, so that would be minus. So it'd be 2x plus 3, 3x minus 4.
Okay.
Okay, go fix those.
You take out a.
I take out a negative 16.
Oh, yeah. you
T
can-
squared minus t minus 2, is that correct?
Yeah.
And then you're going to get 0 equals negative 16. Eden, can you show Evan what we did yesterday? And then we're going to have t minus 2, t plus 1. So that's going to give me two places where it equals 0. So we're going to hit the water at 2 seconds and at negative 1. Which one do I obviously throw out? Because they said t has to be greater than or equal to 0. So we hit the water at 2 seconds.
This page.
What is Hayden's velocity at impact?
Right here.
Well, you know you're going to hit the water at 2 seconds. You want to know the velocity? Well, how do we find velocity? The derivative of position. So if position is s of t is equal to negative 16t squared plus 16t plus 32, then the derivative is going to be s prime of t is equal to negative 32t plus 16. That's the derivative. So that's my velocity equation. Remember, the first derivative position is velocity. Then you plug in 2. So v of 2, or s prime of 2, would be negative 32 times 2 plus 16 times 2, which will give you negative 64 plus...
Why does 16 still have a T?
Oh, that's a good question. 16 should not have a t anymore.
Yeah.
The derivative of 16t is just 16. Thank you. Negative 32 times 2 plus 16.
64.
Negative 64 plus 16, which is what?
Usually gives me like
Negative 48 again, and that would be feet per second, which tells me we're moving down. We're going down, which obviously, when you hit the water, which direction were you moving? Down. Number 5, a small rocket is shot upward from the surface of the Earth with an initial velocity of 120 meters per second. So there's where that V naught T is. See that 120? Shot upward, and it's positive, so it's upward. The rocket goes up, up, and away. That's why it's positive 120. The position of the, and by the way, where's the constant? Why is the constant 0? Where's the rocket shot from?
Space.
No?
Ground.
The ground. You're shot from the ground, so that's why there's no initial height. Okay? So the initial height, 0. This time it's not negative 16, it's negative 4.9, so it's half the gravity constant. What's the gravity constant in meters?
bottom number front.
Feet, it's negative 32, negative 9.8. What's half of negative 9.8?
So this was 1/2. So
4.9.
Negative. That's why there's a negative 4.9 there, half the gravity constant. Okay? Those will be given. You don't have to come up with those. But I just want you to know where they're coming from.
Yeah.
Where is the velocity equals 0? I just got to take the derivative and do what?
Set it equal.
Set it equal to 0. Watch this. When you take the derivative, watch what you get. Negative 9.8t. And if you took the derivative of again, you would get down to acceleration, and it would just be negative 9.8. Set the derivative velocity. Set the velocity equal to 0. So d0 equals negative 9.8t. You get it?
yeah.
Okay. Got her?
I think I messed up on this.
You got to put the thetas. And then you're good. All right, subtract 120. We'll get negative 120 is equal to negative 9.8. T, divide by negative, I'll check it for you and put it in the grade book. All right, what is negative 120 divided by negative 9.8? We're going to have to think of a plan for you for wrestling too, because
Yeah, I know, because I'm gonna miss.
I'm going to just get all the videos for you.
That's what I
Okay.
asked.
You'll just have to do some independent learning.
Yeah, I know.
12.2.
What is it?
12.24.
12.24 seconds.
Yeah.
Okay. When does the rocket hit the ground? Okay. When does the rocket hit the ground? So that'll be when the position equals what? 0. So you're just going to take s of t, set it equal to 0. So we have negative 4.9 t squared plus 120 t, set it equal to 0. Factor out a t, right? So we'll get negative 4.9 t plus 120. We already know it's going to be t equals 0 because it started on the ground, right? And then this one right here, you can't double this one because this wasn't the max height. If you would have found the max, and then when it reaches the peak, you can take the max and then just double it because the maximum, the vertex is always right smack in the middle. Okay, so then you get negative 4.9 t equals negative 120. What's negative 120 divided by negative 4.9? Calculator. You'll have a calculator for this. What's negative 120 divided by negative 4.9? Sorry, it's,
4.9.
what is it?
Oops, 1.9, 24.49, yeah.
Is it?
Yep.
24.49, which is not quite. Oh, wait, that would have been double. Because it was when the velocity equals 0, that's when the peak's going to be. You could have doubled that one. I didn't even pay attention. Yeah, you're right. You could have doubled that one because the velocity equals 0 is when that rocket reaches the peak, and that's halfway between where it's going to cross the x-axis. Think of a parabola. It starts at 0, it reaches the peak, and it's going to hit 0 again.
At the same time.
The peak, not the same time, but double. It gets here at 12.24 seconds. It's going to take another 12.42 seconds to hit the ground.
You think so?
Oh, that's physics.
100%.
100%. And here's the crazy thing. 2 or 3. Usually
Okay, but,
3.
like, you're thinking about like the thrust of the rocket.
Don't argue the physics. It's the physics. Trust me, it's symmetric. And that's, you are assuming, you're assuming air resistance is the same on the way down as on the way up.
No.
Now, here's the deal. This is theoretically. Every velocity you go up on the way up,
Look for ones that are.
it left the ground at 120.
Get you this.
It's going to hit the ground at 120. The same velocity, because it'll go up, it'll reach a velocity of 0, and it's going to go back through all the velocities that it went up through, except for now they're going to be negative. So it left the ground at 120 feet per second. It'll hit the ground at a negative 120 feet per second.
Instantaneously leaving the ground at 120.
Yep, and then when it hits the ground,
That's not
If you think about
realistic.
it, if you think about it, it makes
Really
sense.
think about it, right?
the second the thrusters go off, it's leaving the ground with that kind of a force at 120 feet per second. The second the thrusters
no, I
go
know,
off.
but it's like, it would, in real life, it would take more time than just an instant for the rocket to get going that fast.
Yeah.
Well, yeah, we know that. At 0, it's 0. But you're talking about instantaneous velocity. The second
Yeah.
the rocket goes off, then it's going 120
That
feet
makes
per
sense,
second.
I
Yeah.
suppose.
Yeah. All right, now, what is the velocity of the rocket in impact? Well, it's going to be what? This is just, what is it going to be?
Ground?
Negative 120.
Oh, I see.
Now, you could have plugged in what? 24.49, and you should. If you plug 24.49 into this, do it real quick. What's negative 9.8 times 24.49 plus 120? It's going to be close to that negative 120.
You said 9.8.
So, well, here's velocity right here. So take negative 9.8 times 24.49 plus 120, and let's see if does it equal negative 120. Should.
It should be really close.
Should be really close. We rounded, so it's going to be a little off.
Yeah, but we're off by like point
0.001. Yeah, that's close enough. All right, at 15 seconds, is the rocket speeding up or slowing down?
Speeding up, speeding up.
You know.
It is going to be speeding up because it's before. Well, wait a second. At 15 seconds,
Yep.
is that after 12.24?
Yeah.
So
I mean,
why?
It's still speeding up though because
Because it's going, acceleration's negative and velocity is what?
negative.
Because at 15 seconds, velocity will be negative because it'll be back on its way down. And acceleration, we already know, is negative because what's the acceleration always?
From the y equals thing, yeah.
What's the acceleration always?
Y equals in the second graph.
Negative 9.8
And then you're gonna
feet
want
per second squared.
3.
So that's also negative. Because velocity and acceleration are negative, we know it's speeding up. Speeds up or speed increasing. Speeds up or speed
You get,
increases.
because that's getting reduced more so.
All right, number 5, drone. Is this making sense? Is this helping?
Yeah.
A drone delivery service drops a package when the drone is 120 feet above the ground. There's for 120. Rising at 12 feet per second. So there, at the instant it takes off, it has an initial velocity of 12 feet per second. Okay, and this is the drone. okay? When the drone is 120 feet above ground, rising at 12 feet per second, its position, so this is in feet again, so the acceleration constant's gonna be negative 32 this time. How long will it take for the package to hit the ground? Okay, how long will it take? So it's gonna drop, it's gonna come to the ground. So I'm gonna take position and set it equal to what? 0. See how long it's gonna take for the drone to hit the ground. Can you factor anything out? Can't do it. Can you factor anything out? I think you can factor out a 4, can't you? So I factor out a negative 4. That'll leave me with 4t squared minus 3t plus 30. Is that correct? Is that good? And then you'd have to do your slide and glide. Watch, guys. Watch. 9th graders, watch. Slide and glide. Okay. I'm going to show you. I'm using this in calculus, Eden.
It never goes away.
It never goes away. You go 4 times 30. We just learned it, didn't we, yesterday, Eden?
Yeah.
So you got that negative 4 out front. So you're going to have t squared. So Eden, tell them what to do. So you're going to have plus 120. So what you're doing is you got to can I find the factors of 120 that'll add up to give you negative 3? You could use the calculator and go 120 over x.
Probably
Let's see. It's not going to be
10 and,
Come on, let me take, there we go.
10 and 12. It's probably like 9 and something, or 8.
If it doesn't work, we're using quadratic formula. 20 and 6, no.
No, does not work.
Nothing works?
No.
So guess what you're doing? Now, you can't do quadratic formula with the slide and glide version. You have to do it with this. So you'd have to go, and I'd do it with the negative 4 factored out, though, because it'll be reduced a little bit. So b t is equal to opposite of b, which would be 3. Are you working on homework, Kylie? Plus the square root of b squared, which is 9 minus 4 times 30, all over 2 times 4. Is that correct? So we get 3 plus or minus, is that right? Is that right? Oh, wait. I goofed up. Go back. I forgot, when I factored out a negative 4, that was supposed to be a negative 30. So now would it work with slide and glide?
Got it.
Negative 120, would that work?
You kidding me?
Still don't think there's any way to get 3? Okay, so it's not going to work.
5 and
So that 30 is going to be negative now. So you're going to have 9. What's 16 times 30 with your calculator? What's 16 times 30? I don't want to figure that out.
480.
480?
16 times 30, yeah.
Yep. Over 8. So we're going to get 3 plus or minus the square root of 489 over 8. Let's look at Jean's answer key because I don't want to feel like doing the math there.
I think it reduces.
Okay. So yeah, she got weird numbers. So this is obviously quadratic formula. So the plus one's going to give you the answer. Yeah, so you're going to do 3 plus the square root of 489. Do it real quick. Do 3 plus the square root of 489. Do it. And then after you get that answer, divide by 8. Or you can alpha X it and type the whole thing in.
You'd have to reduce it, right? If it's the.
No,
if
you
get a
can-
Calculator, you wouldn't have to.
No, you just do you just
say
do a decimal.
3 plus.
You got to do a decimal.
But you got that's what I was asking.
Yeah, you got to do a decimal. What do you get?
That's what I forgot to add. 489.
I just put 3.
So 3 plus square root of 489 over.
It's
It's
3.139.
Yep, that's what she got. And that's seconds. And then what's the speed of the package at impact? You would just take this answer and plug it into what? No, not the equation.
TLG.
What?
What's the speed of the package at impact? Pay attention. What's the speed? Speed is what?
Oh.
Velocity.
It's the absolute value of velocity. So you're going to have to find velocity. What's velocity?
The derivative.
Derivative of position, which will be negative 32t plus 12. And then you're going to plug it in, and you're going to get a negative velocity.
Pretty much.
You're going to get a negative velocity. So you're going to have negative 32 times 3.139, and then plus 12. And then when you get that answer, it'll be negative, but speed is the absolute value of velocity. So you would just take the negative and do what with it? So the velocity at 3.139, type that in the calculator for me. What would that be? Negative 32 times 3.139 plus 12, and we'll stop here. Negative 32 times 3.139 plus 12.
3 point.
And plus 12.
It'd be a negative 112.448.
So that's your velocity, and that's in feet per what? Second. So my speed would be positive 112.448. Because speed don't care about which direction you're going. I just want to know how fast you're going. So speed's the absolute value of velocity. That was good. Okay, I'm sure I'll finish the rest on Friday.